Hi class, Mrs. Goodman here. Welcome to our videocast for lessons 6.4 to 6.8. This will help you prepare for the upcoming quiz. If you do not have paper and pencil and a calculator, go ahead and get those items right now and I'll wait here for you. Okay, let's start off with lesson 6.4, which was multiplying integers. Now for the next two lessons, I do not want you to use your calculator. I want you to focus on the rules that we have here for multiplying integers. The first rule tells us that the product of two integers with the same sign will always be positive. So a negative 8 times a negative 5 is going to be a positive 40. The product of two integers with different signs is always going to be negative. So a negative 8 times a positive 5 would be a negative 40. Using those two rules, can you complete the 6 problems below? Pause the videocast and I'll wait right here for you. Okay, welcome back. Now in number 1, I hope that you remembered to add your positive signs. You do need to put those in this chapter. Every number must have a sign. So we take positive 3 times positive 8, we get a positive 24. In number 2, we add our positive sign, and we have positive 9 times negative 7 is a negative 63. In number 3, we add our positive sign to the 4. Negative 10 times positive 4 is a negative 40. In number 4, we have two negatives, negative 24 times negative 2, so that's going to give me a positive 48. In number 5, I want to add a positive sign to that 3, and I have a negative 13 times a positive 3 would be a negative 39. And finally, in number 6, I'm also going to add a positive sign here, and that would be positive 5 times negative 20, and that's going to give me a negative 100. Well, I hope you did well with those rules. Let's take a look at lesson 6.5 on dividing integers. The rules for dividing integers are exactly the same. If the signs are the same, the answer is going to be positive. If the signs are different, your answer will be negative. And you can see from my two examples, negative 40 divided by negative 5 is going to give me a positive 8. And here, where the signs are different, negative 40 divided by positive 5, it will give me a negative quotient, negative 8. I'm going to take a look at number 7 through 12, and if you want to pause the videocast while you work on these, I'll be waiting right here for you. Okay, welcome back. I'm going to add my sign in here, so I have a positive 20 divided by a negative 4, and that's going to give me a negative 5. For number 8, negative 15 divided by a positive 3 is also going to give me a negative 5. Number 9, I'm dividing two negatives, so my answer is going to be a positive 3. In number 10, I want to add in my positive sign with that 9, and that's going to give me a negative 6. Number 11, I have two negatives, so my answer is going to be a positive 6. And in number 12, I'm going to add in a positive sign to that 90, and that's going to give me a negative answer of negative 10. All right, let's move on to lesson 6.5, the second part, where we were converting temperatures. This is where you can use your calculator. And we take a look at the rules for converting Celsius to Fahrenheit. Remember, Celsius is always our smaller number, so we want to do things that are going to make my number greater. You'll see my first step is to multiply, and we're going to multiply times 1.8. And my second step then is to add on 32 degrees, and that result will give you the temperature in degrees Fahrenheit. So take a look at my sample problem, 15 degrees Celsius. In order to convert that to Fahrenheit, I'm first going to multiply it times 1.8. I get 27, and then I'm going to add 32 onto that product to give me a total of 59 degrees Fahrenheit. Go ahead and use your calculators while you work on numbers 13 and 14, and I'll wait right here for you. Okay, welcome back. For number 13, you should have taken a negative 45 times 1.8 to give you negative 81, and then add 32 onto that to give you a negative 49 degrees Fahrenheit. In number 14, you have 120 degrees Celsius that you're multiplying times 1.8. That gives you 216, and when you add 32 onto that, it gives you 248 degrees Fahrenheit. Now we have this very similar formula for converting Fahrenheit to Celsius. Notice that we're using the same numbers, but this time, because we want to make it into a smaller number, we're going to first subtract 32, and then we're going to divide by 1.8, and that result would be the temperature in degrees Celsius. If you take a look at my example, 59 degrees Fahrenheit, I'm going to first subtract 32 from that, and then I'm going to divide that 27 by 1.8 to give me 15 degrees Celsius. Now remember, using the order of operations, if you're putting this into your calculator is going to want to divide first. So you want to make sure when you do your subtraction in the calculator, you either hit the equal sign or you use the parentheses in the calculator to set the order of operations there. Okay, you have two problems, 15 and 16. Pause the video cast while you try those. Okay, let's welcome back, and let's take a look at number 15. We have negative 49 degrees Fahrenheit. We're going to subtract 32 from that to give us a negative 81, and then the negative 81 divided by 1.8 is going to give me a negative 45 degrees Celsius. Taking a look at number 16, I have 248 degrees Fahrenheit. I'm going to subtract 32 from that to get 216, and then divide it by 1.8 to get 120 degrees Celsius. Okay. Let's take a look at lesson 6.6, which would be rational numbers. To show that a number is rational, remember that we write it so that it looks like a fraction in fraction form. And if you take a look at my example here, the whole number 12 written as a rational number would be 12 over 1. Go ahead and take a look at numbers 17, 18, and 19. Write those as rational numbers. Pause the video cast while you work. Okay, welcome back. Taking a look at number 17, this decimal 0.5 is 5/10. I'd write it as a fraction, 5 over 10, and I would simplify that to 1 over 2. In number 18, a negative 1 and 1/15 would be a negative 16/15. And in number 19, a negative 1/2 is still a negative 1/2. Now, as we continue with rational numbers, we look at two really important vocabulary words. Additive inverse, which means the opposite of any number, and multiplicative inverse, which means the reciprocal of any number. So if you take a look at my fraction 3/4, I'm going to put my positive sign in. We want to put our signs in everything in this chapter. So the additive inverse would be the opposite of any number. So the opposite, if you think of a number line, would be a negative 3/4. And the multiplicative inverse, the reciprocal, would be a positive 4/3. In my second example as a decimal, this would be 6/10. And I'm going to write it as 6/10. I'm going to simplify that to 3/5, and it's positive. The additive inverse would be the opposite, which is a negative 3/5. And the multiplicative inverse would be the reciprocal, which is a positive 5/3. Look at the three problems that you just did with rational numbers, 17, 18, and 19. Could you now add on the additive inverse and the multiplicative inverse for those three problems? Pause the video cast while you work. Okay, welcome back. Take a look at number 17. We made that into 5/10. We simplified it into 1/2, and it's a positive 1/2. The additive inverse would be the opposite, which is a negative 1/2, and the multiplicative inverse would be the reciprocal, which is a positive 2 over 1. In number 18, we said that that was a negative 16/15. So its additive inverse would be the opposite, which is a positive 16/15, and the multiplicative inverse would be the reciprocal, which is a negative 15/16. Finally, in number 19, we know that negative 1/2 is still a negative 1/2 as a rational number. Its additive inverse, its opposite, would be a positive 1/2, and its multiplicative inverse, the reciprocal, would be a negative 2 over 1. Now this video cast is going to be continued, so 6.6b to 6.6 or to 6.8 are continued. Please find the link on my webpage so that you can link to that and continue our video cast.